Hey Wildcats, today we're going to be using the notes for the real number system. If you'll notice this first page, we've got a box here and we're going to break it up into two categories. We've got rational numbers and we've got irrational numbers. What I want to do is focus first on rational numbers. If you will, make sure you have some writing utensils, and I like to use my highlighter for this. Rational numbers are going to be any number that can be written as a fraction, meaning A over B. They're including our regular counting numbers, our negative numbers, anything that is a terminating or repeating decimal. So let's think of some examples of rational numbers. Something we like to think of, a normal regular counting number could be like 15. Negative numbers, negative 36. Terminating decimal, that's going to be a decimal that ends, so like 4.35. Or a repeating decimal, anything that has a denominator of 9. Now, this rule for a denominator of 9 is one that we talked about in fractions. So, for example, if I had 0.7 and it's repeating, even though it looks like a decimal, remember a repeating decimal is a rational number. 0.7 repeating is the same as saying 7 over 9. Another example is if I have 0.3 repeating, that's also saying 3 over 9, and we can actually simplify 3 over 9 to be 1/3. Looking at this again, if you had the repeating decimal 0.6, we would put that 6 over 9, and you would simplify 6 over 9 as 2/3. These again are all examples of a repeating decimal. Using this same format of having a fraction over 9, if we had 0.54 repeating, we're going to use that same rule, and we're going to put 54, not just over 9, but since it's in the tenths and the hundredths place, we're going to put it over the number 99. Now, if you will, I'm going to put a couple more so that you know if we had like the square root of 25, the square root of 25 would be 5. That is also a rational number. Anytime we want to take a regular number and make it into a fraction, remember, you just put it over the number 1. So the square root of 64 equals 8, and I can turn 8 into 8 over 1. Now, to go into a different type of real rational number, we're going to talk about integers. So integers are whole numbers and their opposites. So whole numbers are numbers we've been using all year, and their opposites are going to be negative numbers. For example, 80 or negative 45, negative 12, positive 14. You can even use the example 0 in here and positive 16 again. All these are integers. Now, if we're talking about whole numbers, these are our counting numbers, including 0. Okay, anytime we're counting on the number line, we still see the number 0, so this is considered a whole number. So remember the numbers 0, 7, 5, 17, even like 74. These are my whole numbers. So if you're thinking about this in different sections, okay, I'm trying to keep it color coordinated for us so that you see what we're talking about. The last one that can kind of be confusing is natural numbers. Now, when I'm teaching you how to count, or your kindergarten teacher was going over it, when we're counting numbers, we don't normally start with 0. So when we're counting, we think of 1, 2, 3, and eventually you get up to big numbers like 200, 4,000. This is us counting. What we want to make sure we remember is that we're excluding 0. Make sure that you have these notes written down, and once you do, select the next video.